Welcome students to the AVM classes. Today we are going to start a new chapter, exponents. A number 10,000 can be written as the product of its factor, that is 10. On multiplying 10 4 times, we will get 10,000. We can also write it as 10 to the power 4. Similarly, 32 can be written as the product of its factor, that is 2. When we multiply 2 5 times, we will get 32. So it can be written as 2 to the power 5. From here, it is clear that any number can be written as the factor raised to a certain power. So, if we multiply any number n times, it can be written as a to the power n. Exponents are also called powers or indices. The exponents of a number says how many times to use the number in a multiplication. For example, 8 square can be written as 8 multiplied by 8, which is equals to 64. And here 8 is known as base and 2 is known as exponent or index or power. Now let's have a look on few rules regarding exponents. Our first rule is product rule with same base. If we multiply two numbers having same bases but different powers, then we have to add the power. That is, a to the power n when multiplied by a to the power m will be equals to a to the power n plus m. For example, if we multiply 2 to the power 3 and 2 to the power 4, here 2 are the bases of two numbers which is same, and 3 and 4 are the powers which are different, and that can be written as 2 to the power 3 plus 4, and that is equals to 2 to the power 7, and which will give us a result of 128. Our second rule is product rule with same exponent. If we multiply two numbers having different bases but same power, we can write it as the product of two numbers within bracket, and we can use single power, that is a to the power n when multiplied by b to the power n can be written as a multiplied by b in bracket to the power n. For example, when we multiply 3 square and 4 square, then we can write it as 3 multiplied by 4 in bracket to the power 2 equals to 12 to the power 2, which is equals to 12 multiplied by 12, and that is equals to 144. The third rule of exponent is quotient rule with same base. When we divide two numbers having same base but different powers, then we have to subtract the power. That is, a to the power n when divided by a to the power m equals to a to the power n minus m. For example, when we divide 2 to the power 5 by 2 to the power 3, then it will be equals to 2 to the power 5 minus 3. So it is equals to 2 to the power 2, and that is equals to 4. Our next rule is quotient rule with different bases. When we divide two numbers having different base but same power, then we can use single power for both the numbers, and the numbers are written within bracket with division sign. On applying this rule on 4 to the power 3 by 2 to the power 3, it can be written as 4 by 2 whole to the power 3, which is equals to 2 to the power 3, and that gives us 8. The next rule of exponent is the power rule. If we have two or more than two powers for the same base, then we can multiply the power. That is, a to the power n whole to the power m can be written as a to the power n into m. For example, 2 to the power 3 whole to the power 2 can be written as 2 to the power 3 into 2, that is equals to 2 to the power 6, and which gives us the result of 64. The next rule is power rule with radicals. Mth root of any number, say a, raised to the power n can be written as a to the power n divided by m. For example, square root of 2 to the power 6 can be written as 2 to the power 6 divided by 2, that is equals to 2 to the power 3, which is equals to 8. Our next rule is negative exponent rule. Any number raised to its negative power can be written as 1 divided by the number raised to its positive power. That is, b to the power minus n equals to 1 divided by b to the power n. For example, 2 to the power minus 3 can be written as 1 divided by 2 to the power 3, and that is equals to 1 divided by 8, which gives us 0.125. The next rule of exponent is zero exponent rule. Any number raised to the power 0 is always equals to 1. For example, 5 to the power 0 is 1, minus 5 to the power 0 is also equals to 1. Thank you for watching. We will solve exercise related to this chapter in our next video.